Presentation. My name is Natalie, and the in the room is Laura, and I'm programming sub-lead for the team. Laura's a programming manager, and we'll answer any questions you have. Right, so I'm going to be talking about what code organization is and how we manage code. And before I start with that, I'm going to talk about repositories, some benefits of organizing your code, command base, which is how we organize our code, some to-dos and don't-dos, and how you can get started, and there'll be time for questions if you have any. Alright, so generally speaking, code organization is a set of standards or rules or techniques you set for yourself or your team in order to make your code easier to read and understand. Before we get too far into specifics, I'd like to preface by saying that everything I talk about in this workshop is a suggestion. There's no one specific way to organize code, and there are many different ways you and your team could organize your code, and it doesn't have to be like this. These are just standards that have worked well for us in the past. Alright, so to understand how we manage our code, we're going to have to talk about repositories for a little bit. So a repository is a place where data is stored and managed, and you can keep different versions depending on what kind of repositories you use. And so in this picture you can see your repository holds all your files from one version, any files you might add, or any changes you might make in those files in another version, and it saves all those, and it makes it easy for you to go back to any other version you might need to use if your code stops working, or if you really mess something up and you want to go back to how it was before. And so we personally use Git-based repositories and GitHub to manage our repositories, but there are tons of other kinds of repositories. And for instance, one of those is Mercurial. And they both track changes to files over time, which is the version control thing. But Mercurial has a completely different branching system from Git and GitHub. And I'll talk about branching a little bit in the next slide. But Git's branching system is a lot easier to understand and to navigate than Mercurial's. And so we use GitHub because it's a really easy way to share Git repositories between computers, and everyone can work on the code whenever they want. They all get every version, every kind of way it's been, so that they can edit and work on, and they can push it up to wherever. And so this is an example of branches, and it's not a very good example because the branch train is really long and there's no way for me to take a picture of it all at once, so I'm going to have Laura pull up. It's open on another tab. You're welcome. And so we can look at it a little better and see the network graph over time.
Ah, there it is.
Yeah. So this is the end of our 2022 build season code from this past season. And so this is how we ended up with all our code branches. If you hold control and then like left arrow, it'll go all the way to this stuff. Or it shouldn't. Or if you just hold it up there.
Ow. Sorry.
And so we start out every season with our master branch, and every other branch pulls down from branches off from master. And so that blue branch that you're going to see through pretty much the whole thing is our build season branch, which we just use for the whole build season, so that every point in build season you have a safe area of code to go back to if you change something and all of a sudden it's messing everything else up. And so each of those other colored branches are probably competitions that we went to. We created different branch, so any changes we make at competition, if they work, we can keep them and integrate them back into build season, and if they don't work, we can just let the branch go and never go back to it and just revert back to build season. And then each of those dots on every line is a different commit from a different time someone pushed code. And you can also go back specifically to a specific commit or before a commit instead of just the whole branch if you want to be more specific with where you're at. And so that's all those. I think there's one towards the end that like just stops so we don't push back into build season. It's like, I think it's like one, the delete.
Yep.
The delete sheet or delete tab.
Catapult ends
Yeah, because we changed our shooting mechanism after Duluth from a catapult to a shooter, so we no longer needed any of the catapult code, so we just left it there and made a new branch and moved back to build season and continued on. We go back to the slide. And the next slide. And so, as I talked about commit messages, here's a nice little example commit message for you to look at that is not super descriptive, but you don't have to be super descriptive with your commit messages. The best part of the commit message is that you can just go back to it and quickly find out, hey, something changed in this, who changed it, and what exactly were they changing. So that's all you really need to include in a commit message is, if you were messing with the intake, or if you just created a new intake command, you would title it like intake command, and then be like, I made intake run command, or intake stop command. And you put the time that you committed it so that people can usually find this changed at this exact moment, so I know that if I was looking at it before then, I wouldn't have seen that, and if I look at it after, if you pulled your code, then you'll be able to see it. And so I also have the steps for how we push code. So you have to review the changes that you've made and make sure there aren't any merge conflicts with anything else, and make sure you haven't deleted something super duper important that makes the whole thing work. And then once you've got that, you can save your changes, which I didn't get a good picture of, but when it's down in the little, like if it's down here in the little changes area, when you hover over it, there'll be a little plus sign, and you just hit that, and it'll go up when the stage changes, and you can write your little commit message about what you were doing. And then after that, you want to make sure you pull every single time before you push, because you never want to push code unless you have the most updated version of your code space, or you might overwrite someone else's stuff, and then we're going to have to spend 20 minutes going back and figuring out who overwrote what, and re-pull and fix the branch, and it just takes forever, and you don't want to do that. You have to find someone who hasn't pulled yet and be like, don't change anything. Leave it alone. And so now the benefits, the main point of code organization is that to make your code easier to understand in the future. So if you organize your code well and you add comments everywhere, it should be easy for anyone to figure out what you're trying to do, and for them to go back and change it, or for you to go back and change it if it's been like a month and you have no idea what you're doing. If you left good comments and it was well structured, it's way easier to figure out, hey, I was working very closely on this part and this is what it's supposed to be doing, so I can just keep working on that. Instead of you just have a wall of text in front of you and you're like, I have no idea what this is supposed to be doing, and I feel very overwhelmed, I'm just going to delete it and start over, so you can continue on. And it's also easier to catch problems when your code is laid out nicely, because you can easily see this specific thing isn't working, so you can just go find that specific thing. And instead of having to read through hundreds of lines of code, be like, what thing is the problem, and where did I put that, and how do I fix it? Okay, and now we're going to talk about classes. And so a class is just the bare bones outline of what an object could look like or do, and then an object is a version or an instance of that class that has specific traits. So in other words, an object is just a class with a personality. So like, take car for example, all cars start out with the same bare bones blueprints, doors, wheels, an engine, they can move, but not every car looks or acts in the same way. And so a class lays out every variable or trait that a car could have, and any method, which would be something that a car could do, like speeding up or slowing down. And then, because we use command-based code, all of our classes are split up into subsystems and commands. And so subsystems contain things like hardware, which are motors, and you would use that to like set your motor speed, get your motor speed, things with the motors, or other hardware similar to that. And then you use a command to define what that motor can do, or what other motors it can work with to accomplish whatever task you're trying to get done. So sticking with the car example, something like making your car drive forward 10 feet would be a command. And so the biggest tip with method organization is name your methods what they're doing if they're in the subsystem, so that it's way easier to remember what this is doing, especially if you forget to leave comments or someone else wrote it and they didn't write comments. If it's named what it's supposed to be doing, then it's way easier to be like, that's get motor speed. It's supposed to be getting the motor speed. And if it's not doing that, you can just fix it right then and there and move on. And so, we'll move on, next one. And so, these are two classes, the command class and subsystem class. I wanted to ask if you can spot any differences right away between this top part of the class.
The command class is extending command base. Subsystem is extend subsystem base.
And so extends means that the functionality of the class you're extending, which is the parent class, so in this case that would be command base, is given to the child class, which in this case is endgame arm reverse command. And so the child class has all the functionality of command base and also of the endgame arm reverse command. So it can do anything that's in command base and anything that you put in endgame arm reverse command. I think that's command. And then I have another one with the methods part of a subsystem. This is the subsystem one, and the bottom one's the command one. So what's the difference here with these methods? I'll give you a hint. It partially has to do with the naming of them. Yeah.
There's setting versus getting values.
Sort of. So subsystems are usually setting and getting values like from a motor, whereas commands all have the same kind of setup. They all use initialize, isFinish, end, or whatever else you have in there. Because in a subsystem, you're saying what the motor can do, but commands all run the same way. They start, they end when something happens, or they keep going if something else happens. But so all commands have the same couple methods that they can use, whereas in a subsystem you can create more methods. And the other thing I want to talk about with this is @override in the command class. And so @override means that the child class is overriding the parent class. So because all command classes use these same methods, if you're extending a class, it's going to go with the parent class unless you use @override. So if you want your command to do what's happening in the current class and you have extends command base, you want to override so that it'll do what you coded in there and not whatever is lurking in the command base. And so I've talked a lot about command base. We use command-based programming, which centers around those two main concepts, subsystems and commands. And as I already talked about, subsystems contain hardware, like motors or sensors, things like that. And commands use those methods from the subsystems to accomplish a certain task. And so, some commands are triggered when a certain criteria is met, like pressing a button, and other commands are automatically run through a command scheduler, which runs every 20 milliseconds, and you don't really have to worry about it because the command scheduler just automatically does whatever it's going to do when you put stuff in there. And so there are other ways you can organize your code called design patterns, things like timed robot and iterative robot, and so they use periodic functions that run every 20 milliseconds, and we don't use those because they take, as you can see in the example pictures, a lot more logic because they reiterate, they reuse. So with command base, you can just say, when this button presses, this happens, whereas with iterative, it has to check it every single time it reiterates, whereas with command base, it doesn't have to recheck it because it already knows the thing is happening. And so, as I also talked about, every command uses these same couple methods, initialize, isFinish, end, and there's a couple other ones, but these are the big main three ones that you're going to see in pretty much every command. And so initialize is when you start the command, it just says what the command does when it starts. So in this case, when this command starts, it sets this motor speed to arm speed. So it'll be going that speed until the command ends or something happens. And so in this instance, it's tied to a button. So when you press the button, your arm starts moving. And so that's why isFinish returns false, because you don't want it to return isFinish ever, because it's tied to a button, because if it returned true for isFinish, it would just end without you letting go of the button, and you want it to end when you want it to end, which is why you kind of return false is finished and move it on over to end, and at end you stop your motor, and that happens when you let go of your button, because that's when the command ends, is when the button is released. And so command-based programming makes it easier to create new commands because all classes follow the same functionality, and there's a common standard that you match with every single one you make. Alright, and now here are some constants and variables. We keep our constants and variables at the top of the class so that you can then initialize them in the constructor. And you notice we use all private variables. It's because there's public variables and private variables. So public variables can be accessed in any class, wherever you want, whereas private variables can only be accessed in the class that they're in, and they can't be overwritten. And that second part, that they can't be overwritten, is why we use private variables, because they can't be changed by other things outside of this class, really. It's going to stay with this number that you put here every time. You don't have to worry about it getting messed up by some other command, or if you link it with something. So it should all stay right there. And so this is a constructor, just to show the example of how we pass our all our variables in the constructor, so that you have them and you can use them throughout all your methods, and that's why you keep them at the top, so then you can then use them throughout the rest of the class, and you don't have to worry about, wait, did I put this method above that variable I needed to use in it, and now do I have to reorganize everything? Because all the variables and constants are just at the top, so you can use them in any method that you need throughout the class. So now we're going to talk about the formatting part of code organization. So we use different cases, which you are probably familiar with, to make the code easier to read, and that makes it way faster to identify what you're looking at. So you'll know whether it's a variable or a constant, as in like 2 slides ago, just based on the capitalization. So we keep our constants all caps and snake case, which is the middle one with the underline. And so then you know that that's a constant, that stays the same. And then variables are camel case, and so you can easily see. So if you don't properly space out your constants and variables, even without the spacing, you can still see that one that's all caps, that's a constant, and that one that's camel case is a variable. And so then we also use different letters to identify different types of variables. So M_ for member variables, which are variables that are only in objects, so something like a motor or a subsystem or command. And then static are variables that are created on the robot start, and global are available to everyone once they're created. And I couldn't find any examples of us using static or global variables anywhere, so I think we mostly just stick with the member ones. And then the final thing is the tabbing, which I've kind of danced around a lot this whole time. But proper tabbing really depends on like who you are and who your team are. Because one person can tab it one way and be like, that's super easy to read. And another person can come look at it and be like, this is absolutely terrible. I have no idea what's going on here. And so tabbing properly all starts with what your kind of goals for your tabbing are. We usually try to keep everything lined up. So like if you have an if statement, the if and the else line up. And then the things that are in the if are indented over and else. And there's better examples later on. And so next we're going to talk about most important part of code organization, which is the comments. And so without the comments, no one knows at all what you were trying to do, and it's way harder to work on code that you didn't make or that you came back to way later and you have no idea what it was trying to do. And it's harder to fix it because you don't know what's supposed to be going on there, and it's just a wall of text with no explanation or rhyme or reason. And so one way you can keep track of all your comments is Doxygen. We used to use Doxygen because some of our teammates like their system, and it compiles code comments into an easy to read and share HTML file that shares the code structure, and it supports a lot of common code languages. So it saves files by writing and compiling the documentation, And we stopped using it because some people weren't using it and some people weren't following the standards, so there were gaps and conflicts in our documentation that just didn't make a lot of sense. So it didn't work for us as a tool, but it could work for your purposes. And so the main way we use comments is these three right here: single line comments, multi-line comments, and JavaDocs. And the main one we use is JavaDocs. We have JavaDocs above every class, every method, and above the constructor. And they all have that like HTML title and then a description of what's going on. And if there's any like parameters or return things, there will be a little descriptor thing for that too in there. We don't really use multi-line comments, but they're good for if you have something complicated to explain and it's going to take more than one little short single line comment to fit in the space you have. And single line comments we use a lot for like at the end of some complex logic, just like this is what this was doing. Or if you have an equation, you can just throw a single line comment in there that explains the numbers or variables that you use in your equation, just like this is where we got the numbers, this is what this unit is, and this is why we have this here. And so now we're going to do good comment, bad comment. So I have two similar comments here. One of them is, they're not bad, but one of them is worse than the other. So does anyone have a guess which of these comments is not as good of a comment? Yeah.
Bottom one?
Yeah. So why would that be less of a good comment?
Because it all says that it controls the intake motors. It doesn't describe how it controls. Like it's not telling you if it's running them forwards or backwards, or if it sets it to a specific speed, or if it takes in a variable speed, or what.
Yep, that's exactly the reason. And then also, if this is just like a side little thing, they spelled controls wrong, but that's okay. You're gonna have some typos something. All right, here's another one. Good comment, bad comment. Any guesses? Yeah.
The good one is the top one because it describes what the method does and when it's called.
Yeah.
And the bottom one doesn't say anything.
The bottom one has absolutely nothing going on there. They just put the header, but you already kind of know it's initialized because that's what the method's called. So that's like the least important part of the Java doc. You don't have the description of what's happening in the initialize. All right, and we've got one more good comment, bad comment.
Bottom right one is the good one because it shows what the parameters are and describes what they do, while the top left one only just shows the parameters.
Yeah, that's exactly right. The bottom one has nice descriptions for everything that's going on in there, and the top one gives you some parameters, and you have no idea what they are or why you need them there at all, and also subsystems spelled a little wrong, but that's okay. All right, and so now we're on to the what not to do stage. And so hopefully with all I've talked about, can you tell me what is wrong with this code?
Everything.
Pretty much, yeah. Any little specific things jumping out at you right away? Yeah.
Tabbing.
Yeah. The tabbing is all over the place. Anything else?
It's unreadable.
It is pretty unreadable. There's no way to follow where anything's going. There's one more big thing that I said was the most important thing that's not here at all.
Commenting?
Oh yeah. Isn't it? Yeah, commenting. There's no comments here at all. You have no idea what's going on here. It's impossible to read, and nothing lines up with anything else that it relates to. So it's just a whole big mess of code. And so here is that code formatted in a nice way with all the comments, all the headers. Everything is tabbed so that it lines up in a way that you can read it and understand it. And so this is a good example of how you could just take that other code and just space it out a little bit, line things up a little better, and then put your comments in and explain what you were trying to do and make it way more understandable. And even without the comments, it's just easier to read when you tab it this way, or if you tab it at all in a way that wasn't like the way it was before. All right, and so now, with all of that, you might be thinking, where do I start with code organization? And so the first place to start is, especially since we're all in robotics teams, you have to actually talk about it with your programming team. What are your standards? What do you guys want to do? And you want to make sure that everyone's on the same page, because some people get really finicky about it and they won't follow code standards they don't agree with. And so you need to make sure that everyone's going to follow these standards and that they are agreeable to everyone. And my best recommendation is to make either a code standards document or a slideshow or something like that. Keep all your standards in one place for anyone who needs to access them, whether they're new to your team or they've been on your team forever and they just forgot what you're supposed to do for this one specific thing. Or you have like hundreds of requirements for your code and you need to keep them all safe. And it's an easy way to teach new members, like, hey, this is how we format, so when they start coding, they just automatically do it that way, and you don't have to teach them after they've already found some way that they do it. So today we talked about what code organization is, repositories, how we at 930 manage our code, some benefits, command-based programming, the do's and don'ts, and where you can get started with your code organization. So thank you for coming to my code organization presentation.